Good morning, dear students. Now, today in this video, we will discuss about the types of organic reactions. The very first reaction is substitution reaction. The word helps us to get the idea about the reaction. Substitute, that means the taking place of one species by the other. That is called a substitute. Right? You have a class monitor in the class. It happens that after a week or after a month, your class teacher replace him, and on his or her substitute another monitor is given the monitorship. Then what is that considered as? Substitution. One species is taking place of the other. Substitution is taking place. To substitute the molecules, that is, to replace the attached species by attacking reagents. That is called substitution reaction. How can we will define? The reactions in which an atom or group of atoms in a molecule is replaced or substituted by different atoms or group of atoms, it is called substitution reaction. Either one atom or a group of atoms, they can substitute either one atom or group of atom. That means if one atom can replace the other atom, or a group of atoms can replace the group of atoms. So here is an example. First is CH4 methane when reacts with Cl2. Attacking reagent here is chlorine. Now this chlorine when reacts with methane, it is passed through the ultraviolet radiation H mu. So first of all, what takes place here? As soon as this chlorine is passed through the ultraviolet radiation, it converts to the free radical. The cleavage of Cl2 takes place and it converts to Cl free radical. Cl free radical. And then it reacts. This Cl will remove or will substitute one of the hydrogen. It will replace one of the hydrogen and it will be CH3Cl, and one of the hydrogen which was replaced from here will go to the another Cl, and HCl is the byproduct over here. So as this substitution is because of the free radical, this is a type of substitution which is called free radical substitution. Right? And the next is electrophilic substitution. In this reaction, electrophile takes place. See here, this is again benzene ring with methyl group, that is methyl benzene, which is reacted with Cl2 again. Now here Cl2 is electrophile, right? Why electrophile? Because it is Cl2. It is already having a positive charge because now it is shared pair of electron is with it and it is existing as Cl molecule. When this is reacted with anhydrous aluminum chloride, at that time this Cl2 is attacking to this benzene on ortho as well as para position Cl2. So when anhydrous AlCl3 reacts, this will be cleaved, and because here methyl CH3 is ortho para directing, it will guide this Cl to take position on ortho and para, and we will get here Cl on ortho and Cl on para. This is one Cl, this is another Cl, right? So CH3 is ortho para directing group. So it will direct Cl, that is molecule Cl2, which is electrophile, right, on ortho and para position. Electrophile, that means the one who loves electron. That means they are seeking the electrons, right? The third is nucleophilic substitution reaction. What is nucleophilic substitution reaction? See here, methyl and bromine is attached to it. Now here, it is reacted with aqueous KOH. So here K positive, OH minus negative. Aqueous, that means when this potassium hydroxide is reacted with the water, aqueous, then what happens? K plus and OH minus get separated and this will attack to the methyl group, and here at this time CH3 plus Br minus. So this Br minus will be a leaving group. It is minus, so K plus will attack to it, and this is CH3 plus, so OH minus will attack to it. So it is attacking reagent and this will be leaving. Substitution takes place here and we get here methanol plus potassium bromide. So here Br will be substituted by OH minus, and as it is having minus nucleophile, that means nucleus loving, it will try to go towards the positive charge because it is negative nucleophile. Clear? So it is called nucleophilic substitution reaction. So only I told in the last video that please pay attention for electrophilic, nucleophilic and free radical reaction because we will be need to understand it in the reactions. Thus in substitution reaction all attacking reagents can attack, that is free radical, electrophilic and nucleophilic. All attacking reagents are there and they can substitute, on which reaction mechanism is followed. Reaction mechanism we will be studying in the next chapter. First, free radical and electrophilic, we will be learning this mechanism of reactions in second chapter, that means next chapter of the organic, and nucleophilic we will study in 12th standard. Now the next type of reaction is addition reaction. It takes place in unsaturated compound. See, addition, that means we are in need to some add. It's not like substitution that instead of one place one is removed and one is taking the place. It's not like that. Addition, that means we are going to add something. Now, is it possible to add something in saturated compound? No, because saturated compound, all the bonds of the carbon, all the valency is completely satisfied. So there is no possibility to add anything in saturated, but unsaturated having double and triple bond, there will be possibility to add something in them. And so addition reaction takes place in unsaturated carbon, that is multiple bonded system is converted to single bond. So what's the definition? The organic reactions in which two molecules react to form a single product. Two molecules, when they will react and will form a single product having all the atoms of the combining units. So if two molecules are combining and they are forming single product, then that product must have all the atoms of combining units. Whoever are combining, that combining units atom should be there in the product. Let us see here an example. CH2 double bond CH2. See here, multiple bond, double bond is present. Ethene is here. When it is having a reacting agent H2 hydrogen, H2 directly will not proceed the reaction. It needs someone help where we are in need to take a catalyst, that is the nickel catalyst. This nickel catalyst will provoke hydrogen to react with ethene, and this hydrogen first will get cleaved and one H will go to this CH and another H will go to this CH, where this pi bond will be cleaved. Simultaneously both cleaving takes place. So from double bond it will be now single bond and it will be CH3 ethane, which is saturated compound. So whatever the units here, see CH2 both are combining, and both whatever it is having carbon H2, it is already present here, carbon H2 and addition of two more H took place. Second example is CH2 double bond CH2 plus HBr. This was homoatom. This is heteroatom. Both H2 homo. Here H and Br. Now here is H plus and Br minus. Right? HBr when it cleave. So H plus will go to this carbon. Right? And Br will go to this carbon on the cleave of the pi bond. And we will get here CH3, CH2, Br. Clear? So if we want to give the name here, what it is? 1 and 2 carbon. So ethane family. But here halogen group is attached. So it is either you can say bromoethane or ethyl bromide. Clear? Now one more, see here, CH3CH double bond O. It is not that addition reaction will take place only on the double bond between carbon and carbon or triple bond between carbon and carbon. It can take place with carbon double bond oxygen also. Now here what will happen, the cleavage when takes place here with HCN, hydrocyanide, H plus Cl minus. At the same time, this pi bond will be dragged by oxygen because compared to carbon, oxygen is more electronegative. So it will drag both this electron towards it and it will acquire negative charge here. So as soon as it acquires negative charge here, positive hydrogen will attack on it. So it will get OH, and this carbon, when both the electrons are taken by oxygen and it will be taking negative charge, carbon will have positive charge. So this Cn with negative charge will attack on carbon. And so what will happen? We'll get CH3, C, Cn, OH and hydrogen as it is. So here OH will take place and Cn will be here, and double bond is now single bond. Addition of OH and cyanide here takes place. Right? Now terminal group here you see this is cyanide group. So we'll consider first carbon here because it is having carbon. Here is functional group but it is not having carbon. So this will be given first number 1, 2 and 3. So on second group we have alcohol. Now in nomenclature we have learned when alcohol is along with one another functional group, and if it is taken as first name then it will be taken as prefix. So on second carbon 1, 2. So 2 hydroxy 1, 2, 3 propane nitrile. 2 hydroxy propane 1 nitrile also we can write. And on first position, if main functional group is there and if we are not writing, then also it is okay, no problem. Right? It also takes place on triple bond, C triple bond N also. Right? The third reaction is elimination reaction, which is opposite of addition. In addition, we are adding something. In elimination, we are removing. Right? In this reaction, or we can say in the elimination reaction, elimination takes place. It means removing takes place of atom from the carbon chain. We are removing some atoms from the carbon chain. Or we can say here, single bond compound is converted back to double bond. Here see, double bond is converted to single, addition. Elimination is opposite to it. So what we can define? The reactions in which two atoms or groups of molecules are removed from the carbon chain, it is elimination reaction. Right? So here let us see one of the examples, CH3, CH2Br plus alcoholic KOH. Now in organic chemistry, the reacting reagents as well as its medium, both are very important. In the previous reaction, if you have remembered, in substitution reaction, we have taken that it is reacting with aqueous KOH. On reacting with aqueous KOH, substitution took place, CH3OH KBr. Now when reacting with alcoholic, right, elimination reaction will take place. So here CH3, CH2Br, 1-bromomethane. It is now converted to ethene, double bond. Here K plus OH minus gets separated. K plus will attack to Br and it will remove. It will not replace here OH. No. Here Br will be removed and it will be a side product, byproduct KBr, as well as one of the H from here will be taken by OH minus and it will be the aqueous medium H2O. So CH2 double bond CH2 will be left out. So this is the elimination reaction. Br as well as H both are removed. See, from first carbon Br is removed, from the second carbon hydrogen is removed. So this is also a type of elimination, alpha beta, right? Beta elimination. So we'll see the types of elimination reaction. Now let us see the types of elimination reaction. The first is alpha elimination. So what is alpha elimination? Elimination we know to remove. But what is alpha? In this reaction, the loss of two atoms or group of atoms occurs from the same atom. So, loss of two atoms will take place, but that too from the same atom, it is called alpha elimination. Or we can say first carbon. When the loss of two atoms takes place from first carbon in a carbon chain, it is alpha elimination, right? So what is here? Here R2, that means two alkyl group is present over here, H and Cl. So two alkyl group 1 and 1. So this carbon 1, 2, 3 and 4 valency will be satisfied. R2, 1 are here, 1 are here. But in a condensed form it is written R2CHCl. From this carbon, H will be removed, Cl will be removed, right? Here H and Cl both are living. So from the carbon, here the carbon is first only. From first carbon, when two groups are or two atoms are removed, then it is called alpha elimination. That is the both will be removed, so two electrons are free now, or we can say one lone pair. This is the carbene, right? Now what is the beta elimination? So removal of the two atoms or group of atoms from the first and second both carbon, right? That is called beta elimination. In this reaction, the loss of two atoms or group of atoms occurs from the adjacent position. Adjacent, that means from here and as well as from the exact side of it, adjacent. When two atoms are beside each other, they are called adjacent, right? Or in a simple form, if we want to remember, it is from alpha and beta position, that is first and second carbon. First carbon is the alpha, the second is the beta, right? Here Br, functional group, hydrogen is attached, so this is the first carbon, right? And here it is H only. So this is first, this is second carbon. Now Br from the first and hydrogen from the second, both are removed by alcoholic KOH, as just we have discussed in a general presentation of elimination. K plus will attack to the Br minus and a byproduct will be considered, and OH minus will attack to H and H2O will be separated medium. Then this both removal is from alpha and beta. That means here beta elimination takes place. This is called beta elimination. And the third type is gamma elimination. In this reaction, the two atoms will lose or loss of two atoms will occur from alpha and gamma position. Not adjacent but alternate. We can say here alternate position. One, then not another, and then the another. So leaving one between two is called alternate. That is from first and third carbon. Suppose we have here CBr, C and CBr, right? Then if we consider these as a alpha, first, second, third, or from here also first, second, third, then the removal of Br and Br from first and third, alternate, see here, from here, not here, adjacent is not taking place. but leaving the between one and then the third. So removal of Br and Br from first and the third carbon, or we can say alpha and the gamma carbon, right? Minus Br2 is removed. Then it has taken position of cyclopropane, and this is called the gamma elimination, right? So elimination reaction and types of elimination reaction are three, which are the alpha, beta and gamma, right? And now let us see the fourth reaction, that is the rearrangement reaction. Rearrangement reaction. In this reaction, rearranging takes place due to which isomers is occurred. When the rearranging of the atoms takes place, then that particular compound which is rearranged, it may exist in the isomeric form. We know what is isomers. Isomers, that means having the molecular formula different, right? Having the molecular formula same but structural formula is different, right? So let us see the rearrangement reaction. Rearrangement reaction involves the migration of atoms or group of atoms to another position within a molecule. See, within a molecule. That means in a same molecule, when the migration, that means when the change of the place is from one position to other, then that is called rearrangement, right? Every now and then, your teacher used to change your position in the class, and mostly this takes place in the younger classes. So student will get the friendship with all, or they will not start getting the close friendship with only few and become a talkative, and many other reasons are there. So by one or the other reason, your class teachers used to change the position in the classes, right? That is called rearrangement, from one place to another within a molecule. Your class is within one only, and in that you are changed, right? That takes place in younger classes, but for your understanding, just I am telling. So rearrangement reaction, let us see an example over here. See here, by mistake, before the types of the elimination reaction, I have written rearrangement, and then I recall myself that types I have forgot. So when you people write, you just complete the types of elimination reaction and then write the rearrangement reaction. So here is an example: CH3, CH2, CH2, CH3, 1, 2, 3, 4, right? So it is butane. It is reacted with anhydrous and aluminum chloride. Anhydrous, that means there is no presence of any moisture in it. And when it is reacted with anhydrous AlCl3, this CH2, CH2, here the change of this hydrogen is with this CH3, and we can have the position like this: CH3, CH3 and CH3. Migration, that means the conversion of this in the same molecule takes place. And this is now 1, 2, 3 propane. On second, it is methyl group, so IUPAC name is 2-methyl propane, or in a common trivial language, what it is? Second carbon chain is there, so it is iso. And now consider all the carbon. So this is normal butane, straight chain. It is branch chain on second carbon, so it is isobutane. Both are having same molecular formula: C4 3339 plus 1 10, C4 3322 10, C4 H10. Same molecular formula but different structure. So isomers takes place, right? And the fifth reaction is condensation reaction. In this reaction, condense, that means to come closer, right? In this reactions, two different or same organic reactions combines with or without elimination of a single molecule to give a product. See, condense, to come closer. So two different or same organic reactions, they will combine together either by the elimination or without elimination and will give a product. Here is an example: CH3 C double bond O, right? Aldehyde group here also, And here also similar CH3, CHO, but I have written CH2 and 1H. So we will easily able to understand how it combines. Right? It is ethanol plus ethanol. Two similar organic compound. They are in the reaction. Here what happened? This 5 electrons, right? They will go to the oxygen. Oxygen being more electronegative, it will drag both the electrons. As soon as it will get electrons over here, this hydrogen is already not having any electron because it has already given to this carbon. So it is always in need of the electron. So it will directly, simultaneously, it will attack to oxygen over here. So what will take place here? CH3COH. This double bond will be now single. CH3COH. CH here it will be, and this CH2CHO will combine here, and we will get CH3CHOH, CH2CHO. Two same or different? Here it is same. Right? They react and combine with or without elimination and give a single molecule as a product. So it is the condensation reaction. Now here aldehyde group is there, more reactive than alcohol. So this will be taking, and even it is having carbon. So this is first carbon, second, third, fourth. On third alcohol is there, but it is now substituent functional group. So it will be prefix. So 3-hydroxy butane 1R. 3-hydroxy butane 1R. And the sixth type of reaction is isomerization reaction. Isomerization. The reaction involves interconversion of isomers, where molecular formula and the carbon skeleton of the reactants and products always remain same. Only interconversion will take place. So mostly it takes place in geometrical isomerization, where the reactant and product skeleton remain same. Only the change in position, interconversion of the position takes place. And here this is our butene. But what type of butene? See here, methyl group and here methyl group. Both are in opposite. So it is trans-butene. When passed through ultraviolet radiation, the trans-butene will be interconverted. The position from here to here, it will be delocalization takes place. But as I explained, that due to double bond, they will not undergo complete rotation. Right? 360-degree rotation won't take place. So here from this position it will just go to this and it will be on the same side. That is the cis butene takes place. So this is isomerization reaction. A reaction in which only interconversion of the attached group or substituents takes place. That is called isomerization reaction. So these are the 6 reactions: substitution, addition, elimination, right, rearrangement, condensation and isomerization reaction. Please go through it properly and try to understand, right? Read it again and again. All the topics, read it again and again, and go through the videos also again and again, so you will understand very easily, right? Thank you.